I've always wondered where engine oil comes from.
You want to know about oil, boy? I know someone who knows a thing or two about that.
What is crude oil used for? Crude oil, once converted to petroleum, is used to fuel vehicles and can even heat homes. It also has the potential to create products such as medicines and plastics. Sourcing, producing, and moving crude oil has many negative effects on the environment, and in most cases, crude oil is not as useful when it's in natural form. This is why it's often purified. During the purification process, crude oil is made into fractions, and these fractions created are dependent on the boiling point of the molecules within. What is crude oil? So primarily it's made out of hydrocarbons, including paraffins, aromatics, cycloalkanes, and alkenes. There are also trace amounts of sulfurs, nitrogens, oxygen, metals, and salts. Because of these additional traces, it causes a multitude of boiling points to occur, and this refers back to the fractions created. So according to the University of Western Australia, the fractions from highest to lowest boiling point consist of heavy gas oil, lubricating oil, gas oil and diesel, kerosene, gasoline, naphtha, and gas. So where is crude oil found? It's found in reservoirs underground. So when we dive deeper, we find that crude oil is composed of built-up organic matter. According to the National Geographic, the type of organic matter includes the remains of ancient marine organisms such as plants, algae, and bacteria. And when we add the addition of factors such as time, temperature, and pressure into the mix, we find the formation of crude oil. So in order to find these reservoirs, geologists use seismic surveys on the Earth, which essentially means that they use an echolocation detection method, and the crude oil is then found through a method of drilling, and the oil is then collected either through natural pressure or siphoning by wells. So what happens to it? Crude oil undergoes a process called cracking, which causes existing hydrocarbon molecules to shorten. And there are three types: thermal cracking, hydrocracking, or catalytic cracking. It's also important to note that it's a volatile oil, with high levels of polyunsaturated fatty acid, means that it's more likely to undergo rapid oxidative deterioration, although its oxidative stability can change depending on the chemical composition of the collected crude oil batch.
But what is all this crude oil doing to the environment, you might ask? Here's Gemma to explain.
Crude oil is detrimental to the environment for a number of reasons. This includes pollution, oil spills, oil drilling, and oil development. One of the major contributors to greenhouse gas emissions is the combustion of fossil fuels. When fossil fuels are burned, this process releases chemicals such as carbon dioxide into the atmosphere. These chemicals contribute not only to climate change, but are also toxic to human and ecosystem health. Additionally, transforming crude oil into petrochemicals is also dangerous for humans, and this process releases toxic chemicals into the atmosphere, which can cause many illnesses and diseases. Oil spills occur during the drilling, transporting, and use of crude oil. During an oil spill, large plumes of oil separate onto the surface of the water and create a very thin layer called a sheen. This occurs as a result of the composition of oil and its density. Oil is hydrophobic, meaning it is repelled by water due to its polarity. Oil is also less dense than water, and as a result floats on the surface. Oil has a strong impact, even if it is far away from the source, leading to a number of issues on the environment. Spilled oil pollutes streams, rivers, and soaks through the soil and rock groundwater, killing plants and animals and altering pH levels and salinity levels. Oil spills also impact human welfare. Oil contamination makes it unsuitable for irrigation and consequently unsuitable for the use of drinking. It only takes 1 litre of oil to contaminate 1 million litres of water. Drilling rigs are used to pump oil out of the ground. They work by oil being absorbed in rock layers similar to the way in which water is absorbed into a sponge. After oil is pumped out, drillers have to extend or relocate the wells after oil has been removed from an area. This diagram illustrates the most common drilling rigs used in extracting crude oil and the depth at which they are used. Infrastructure built for the extraction of oil leaves behind detrimental impacts on wildlands. Roads, facilities, and drilling sites involve the use of heavy equipment and machinery, which can lead to irreversible damage to the environment. Developments also typically remove large amounts of land and vegetation.
Oh, didn't see that. So you're probably thinking, what about the animals?
Well, we've got our resident marine biologist, Ryan Barry, on the scene. Here's Ryan.
As far as impact on animals, there is a number of issues. And for example, turtles, whales and dolphins can ingest the oil through respiration, as well as mistaking it for food. And this really affects their breathing, reproduction and the immune system. Fish, however, are really only affected when the oil begins to mix and travel deeper into the water. And this ingestion or interaction can cause fin degradation, decrease in reproduction, kill eggs, impair growth, and also damage the internal organs of the organism. So next up is probably the largest impact on animals, and that's birds. So when their feathers are soaked in oil, they become really heavy and they separate from one another. And this decreases the bird's ability to waterproof itself, take flight, and remain buoyant. This also exposes the bird to predators, but more importantly, the harsh environment, as most of these birds actually do end up dying from hypothermia. And finally, any ingestion of the oil by the bird can result in dehydration and damage to the gastrointestinal tract. So finally, oil can reach coral reefs during rough seas, low tides, and when the oil starts to mix with sediment. And once on the surface of the coral, it really starts to impede growth, development, and reproduction. And this in turn has a really large impact on the ecosystem surrounding the coral.
So boy, you want to know about the Deepwater Horizon? I was on that vessel when it went up in flames. I've stared death in the face and lived to tell the tale. Here is that tale.
The oil spill from the Deepwater Horizon was one of the largest environmental disasters in recent history. So what happened? The Deepwater Horizon oil rig was owned and operated by offshore drilling company Transocean and leased by BP. It was located in the Mississippi Canyon, a valley in the Gulf of Mexico, about 50 kilometers south of Louisiana. On the 20th of April 2010, an explosion occurred which caused multiple fatalities and subsequently led to approximately 4,900 barrels, or about 500 million litres of oil spilling into the ocean. This is equivalent to about 200 Olympic swimming pools full of oil, or about 56 million cases of beer. This covered an area up to 180,000 square kilometres, or about the same size as England and Belgium combined. Oil spread to a depth of 1,300 metres, about the same as the Burj Khalifa stacked on top of the Empire State Building. Despite the use of response measures such as dispersants and burning, oil still spread across more than 1,700 kilometres of coastline. Therefore, this spill had drastic effects on many shorelines and deep-water ecosystems. The type of oil that was being extracted was a Type A oil. This is low in sulfur and high in gasoline kerosene fractions compared to heavier oils. After the explosion, there was a rapid drop in pressure at the exit point of the oil, creating small and microscopic oil droplets, which was a key characteristic in the dispersal of oil. As the oil generally had a lower density than seawater, it moved upwards towards the surface. Larger droplets moved upward fast, but microscopic droplets had a neutral buoyancy, so were retained in the water column. To clean the oil from water, about 6 million litres of dispersants were used to emulsify the oil, making it easier for bacteria to break down, with the remaining oil having to be burnt off. A study that was published in the Journal of Nature in 2020, 10 years after the spill, found that fish in the Gulf of Mexico continued to show evidence of contamination by polycyclic aromatic hydrocarbons. This is a compound that stems from crude oil and is highly toxic to fishes and humans.
The Gulf of Mexico is a highly diverse region, accommodating 22 marine mammal species such as manatees, dolphins and whales, as well as 5 turtle species, a variety of birds, and a vast coral colonies. This disaster had wide-reaching effects on many different ecosystems within the area, causing deleterious effects on the majority of the inhabitants. As Ryan covered, there are significant detrimental impacts associated with large vertebrates. Detrimental effects such as organ and reproductive failure, decreased mobility, inability to feed and evade predators have all contributed to drastic mortality in the initial event and the years following. Looking at specific numbers related to Deepwater Horizon, it is estimated that 800,000 birds were killed. A 2014 study suggested that 12% of brown pelicans and 30% of laughing gulls in the area were affected by the spill had been killed. This had far-reaching effects for migratory birds such as the white pelican, who, when breeding on the other side of the country in Minnesota, were producing eggs with trace amounts of compounds associated with the oil. Aquatic organisms were also hit heavily, with an estimated 65,000 turtles dead in 2010, the majority due to oil contamination. A further projection of 300,000 turtles from migratory groups were calculated to be passing through the affected area at the time of or after the disaster, highlighting the far-reaching effects of this disaster. Although there aren't exact numbers on the porpoise families, 1,400 individual whales and dolphins were found stranded by the end of 2015, representing a fraction of the true mortality. Additionally, a 30-kilometre radius of affected coral beds was determined, which reduced the reproductive output and slowed the overall growth and success of the colonies. In addition to the 6 million litres of oil dispersant chemicals used to alleviate the spread of the impact of the oil in the water column, microbial degradation of the oil was a key factor in depressing the spill. Different types of bacteria were prominent at different stages of the spill. Oceanoserpentilla and Pseudomonas bacteria were pivotal in the early stages, where N-alkanes and cycloalkanes were the main compounds. However, this shifted towards petroleum hydrocarbons and aromatic hydrocarbons, where Pseudoalteromonas, Corwellia, and Cyclocausticus bacteria became more abundant as they were more suited to the decomposition of such chemicals. From multiple studies looking at deep water environments, they concluded that such microbes were pivotal in the cleanup of these unique ecosystems. Oh, that all makes sense now. Oil really is a pretty dangerous material. On next episode, we'll be investigating engine coolant. Thanks for watching.
Like and subscribe, yeah.